This is question one of like 4 questions that a student, not saying who, submitted to me. So this question says, there's a 70% chance Alex brings an umbrella to work next week if it rains. There's a 10% chance he will bring it if it doesn't rain. The forecast says there's a 65% chance it will rain next week. What's the probability of Alex bringing the umbrella? All right, so there's a few ways to organize this. We're going to first define our events. So we are going to make R the probability of, or the event that where it rains, and then we're going to make U. Actually, maybe not U. Maybe I'll use B. B be like the event that Alex brings an umbrella. Okay, so once you have this, you can just go through the question and write down your probabilities. So basically, the first sentence, 70% chance Alex brings an umbrella to work next week if it rains. That's telling you that the probability of this guy bringing an umbrella, given that it rains, is 70%. Actually, I'm going to use decimals for this. So 0.7, and then the probability of this dude bringing it, if it doesn't rain, this is 0.1, and then we know the probability of R is 0.65. So you can use the like conditional probability formulas. So this is going to be probability of B and R. Oh, sorry, I forgot. We're looking for the probability of just B. So this is B and R. This is going to be the probability of R, and then this is the like B and R, not R. This is going to be the probability of not R. So you could do it this way, and that's fine. The way that you do it this way is because we have this, then like we know that probability of not R is just 1 minus the probability of R. So this is 0.35. You have, so you know here, I'm going to highlight what we know in in yellow. We know what this is because we have it here. We know what this is because we just calculated over here. We're looking for the probability of B. The probability of B has to be the probability of B and R plus the probability of B and not R. It has to be that because if you think about this in terms of a Venn diagram, B and R is here, and then B and not R is this like red portion over here. And I did forget to label that, but this is B. This circle, the one on the left is B, and then the one on the right is R. So we just find these two, and we can because again, we know every value. Like we know we have a number on the left sides of these equations. We have a value like highlighted. Sorry, we know what the values are that are highlighted in yellow. So we can solve for this, and then we can just put them into this equation and get B, probability of B. So this is one way of doing it, and it's perfectly fine if you want to use these like formulas. But my approach to this is using a tree diagram or drawing a tree diagram. And the reason why I would like to do this is because it just, I don't know, it just makes more sense to me this way. And also because the equations can be a little bit finicky. They don't always work out. In this case, we were kind of, well, I think we were lucky that they worked out. But I don't know, I just don't trust equations as much as I trust the tree diagram, I guess. Maybe I should learn to trust the equations, but whatever. All right, so we're going to draw the tree diagram. We're going to have our first event be it raining, and then our second events be like the probability of this dude bringing his umbrella or not. So we already know that like given that it rains, the probability of this guy bringing an umbrella is 0.7. So I can fill in 0.7 on this branch here because this path is it's raining firstly, and then this guy bringing his umbrella. So this path that I've highlighted in yellow represents this probability here. Okay, so then it also tells us with like this thing that if it doesn't rain, the probability of him bringing his umbrella is 0.1. And finally, it ends up by telling it ends the question by telling us that the probability of it raining is 0.65. So that's great. I can kind of just fill in the rest of the tree diagram. So this here is going to be 0.35, because we just do 1 minus 0.65 to get that 0.35. And I could fill in the rest, but I don't need to. I will for this question, just for completeness, but I don't need to. The reason why I don't need to is because we're looking for the probability. Oops, I erased that. We're looking for the probability of this guy bringing his umbrella. And we just find the paths that result or that include this dude bringing his umbrella. And I've highlighted them in yellow. So this is going to be equal to probability of B and R, or yeah, sorry, B and not R. Sorry, B and R. Sorry, B and R. That's the like top path. And we add to this the probability of B and not R. And these are pretty simple to calculate. We just multiply some probabilities. So 0.65 times 0.7, and then we add to this 0.35 times 0.1. Or not 0.1. This should be 0.9. Oh wait. Oh, great. This is 0. Nuts. Okay, that kind of sucks. Okay, I highlighted the wrong path. That should be 0.1. It's because I didn't like put the prime there. I didn't put this prime there when I was drawing the tree diagram initially. Oops. 0.1. So if you go through this, you're going to have 0.49 as your final answer.